In today's lesson, we're going to continue where we left off from the first part of 1.4. We're going to continue to talk about solving equations. We're just going to look at doing that in a few different contexts. So we're going to start by looking at a word problem. This involves, it's going to involve a rectangle. So it tells us the length of a rectangle is 5 centimeters greater than its width. The perimeter is 58 centimeters. What are the dimensions of the rectangle? Dimensions mean length and width. So what are the length and width? What are the two side lengths? How long are they of this rectangle? So thinking back to what you remember about perimeter, I'm going to label the side lengths here of a rectangle just with W and L to represent length and width. And one way to think about perimeter, it's just the sum of all the sides of the shape. In this case, it has 4 sides. So adding up all 4 sides. One way that we might think about writing that, length plus width is equal to the perimeter. And these are like terms here. So 1 length plus 1 length is 2 lengths, so 2L. We can also combine these together to write this as 2W. So this is the perimeter formula that we're going to think about using today. So I'm going to rewrite that over here on the line. And I'm going to clear off some space here. So in the next part, when it says to draw and label a picture, I'm actually going to label a picture specifically for this problem. So we're going to look at some clues in the words. It tells us that the length of the rectangle is 5 centimeters greater than the width. Another way to say that would be that it's 5 centimeters more than the width. And so because the length is based on width, I'm going to actually label the width with a variable. I'm going to use x to represent that variable, but you could use a little w. And if the length is 5 centimeters more than x, then we're just going to simply do x plus 5 to represent the length. So notice how my rectangle here has these nice side lengths labeled specific to our problem. So again, that is representing the width, and this expression over here is representing the length. So for the last part where it says to write and solve an equation, we're going to use the perimeter formula to help us to do that. So I'm going to start by writing 2 times the length. I'm going to need to put this length in parentheses because there's 2 terms involved, plus 2 times the width, which is just 2x, is equal to our perimeter, but in the problem it tells us that our perimeter is 58 centimeters. So notice how now we've turned this into a nice equation that looks similar to the equations that we were solving earlier. So going through our steps, let's go ahead and start by distributing the 2. Then we're going to combine like terms, so the 2x and the other 2x makes a 4x. Okay, so here's an example of an equation that is not going to require us to move the variables because we only have x showing up in one place. It's not showing up twice. So here we are going to use that 4th step, which is add or subtract, and that is to get it so that the term involving the variable is by itself. So in this case, we want to get rid of this plus 10 so that that 4x can be by itself. Thinking about inverse operations, if we want to undo adding 10, we're going to subtract 10 from both sides. All right, now for our final step to get x by itself, if we want to undo multiplying by 4, we're going to divide both sides by 4, and 48 divided by 4 is 12. We're not done yet. Remember the original question was asking us the dimensions of the rectangle. So if x is 12, that means that the width is equal to 12. And remember that the length was 5 centimeters greater than the width, so 12 plus 5 would make that 17. Let's add units onto our answer. We'll put centimeters on the end of that. And there we go. By the way, something that you'll notice that I'm doing here with the L, when I'm talking about length in a problem or in a formula, I like to draw the L with a loop like that. Because if you draw an L like this, what are you going to get confused by? You might think it's a 1. So I would say don't draw your L's that way. You're going to see more L's in a few minutes. Let's try to have it with a little loop in it. Another application to think about with solving equations is looking at literal equations. So a literal equation is defined as an equation that uses at least 2 different letters as variables. You solve for a variable, which means getting it by itself, in terms of the other variables. A formula, just like the perimeter formula that we were working with in the last problem, that's an example of a literal equation. So let's actually revisit that perimeter formula for a rectangle. Suppose we know the perimeter and we know the length, but we want to find the width. So we're actually kind of working backwards. To do so, we could solve the formula P equals 2L plus 2W for W, getting W by itself, with the same principles that were used for solving equations. So here's what that would look like. If we want to get W by itself, first we want to get the term that involves the W by itself. So to get 2W by itself, we need to get rid of 2L. Now that 2L is a positive 2L, so to get rid of it, we're going to put on both sides a negative 2L, or subtract 2L from both sides. So that will cause the 2L to cancel from the right, leaving us with 2W. Now on the left, we can't really do anything with that. Those are not like terms. We just have to keep them separate. P minus 2L. Keep it as it is. Now the last thing that we need to do to get W by itself, W is being multiplied by 2, so we want to undo that multiplication. We'll go ahead and divide both sides by 2. And that's it. If we want to rewrite our answer a little nicer, we could move the W in front and just recopy over P minus 2L, all divided by 2. Now something that I want you to be very careful with here, sometimes students see this and they fall into this trap of seeing a 2 on the top and a 2 on the bottom, and they start to think, hey, I think I can just cancel those out. Because if it was simply 2L divided by 2, then yes, we could cancel the 2 from the top and bottom. But our scenario is a little different because we have this P minus 2L on the numerator. Anytime you have addition or subtraction in a numerator or denominator, you cannot cancel numbers that look the same. So I just want to caution you with that. We're just going to leave our final answer like this. So what's nice about it is that if we know the perimeter, go ahead and plug that number in. For the perimeter, we know the length. We can plug that in for the length. Simply simplify down that right-hand side, and that would help us to get the width. So we're going to finish up by solving a few more formulas, which are examples of literal equations, to get a variable or a single letter by itself. So we're going to solve the formula A equals L times W for L. So that means we want to get L by itself. This is the formula for the area of a rectangle. So right now, L is being multiplied by W. The only thing we need to do to get L by itself is to get rid of the W. Since W is being multiplied, the inverse of multiplication is division. So we're simply going to divide both sides by W, and we're done. You can leave your answer like that, or if you want to write it a little nicer, you can rewrite it like we did above. L equals A divided by W. Let's look at the formula for the volume of a box. Volume equals L times W times H. The H represents height here, and here we're wanting to solve for H. We want to get H by itself. H is being multiplied by two things, L and W, so we need to get rid of those. Because it's all multiplication, we'll do that with division. Now we can actually divide by L and W at the same time. So that's kind of cool. And there's our answer. H, in terms of the other variables, is equal to V divided by L times W. The next formula is for temperature. It's telling you the temperature in degrees Celsius based on temperatures in degrees Fahrenheit. So this is how you can convert between the two. We're wanting to solve the formula for F, so we want to get this the other way around so that we have temperature in Fahrenheit based on whatever it is in Celsius. So one thing that's a little different about this equation, or this formula, that I want you to notice right away, we've got this fraction 5/9 out in front. So anytime you have a parentheses, we want to deal with whatever's outside of the parentheses first. The easiest way to get rid of the 5/9 on the right-hand side is to multiply both sides by the reciprocal. The reciprocal of 5/9 is 9/5. There's something special that happens when we multiply a fraction by its reciprocal. 5 times 9 across the top is 45. 9 times 5 across the bottom is 45. When the numerator and the denominator are the same, it's equal to 1. And 1 times anything is just itself. And so multiplying both sides by 9/5 essentially is a way to get that 5/9 to cancel. So if we multiply 9/5 on the left side, we have 9/5 in front of C. And when we multiply the 9/5 on the right side, that's going to cancel out, make it a 1, leaving us with 1 times F minus 32, which is just F minus 32. And we don't need the parentheses anymore since we don't have that 5/9 anymore out in front. Now all we need to do to get F by itself is simply add 32 to both sides. Because it's subtracting 32, addition is the inverse of subtraction. The way it's going to look on the other side is like this, 9/5 C plus 32. So that's our final answer. One other way you could write this, 9/5 times C is the same thing as 9C divided by 5. So there we go. And then let's take a look at our very last formula, which actually has a similar setup to the temperature formula. This one is for the area of a trapezoid. Okay, so I wanted to draw in the shape for you here. So here's a trapezoid, so we can see the height. The top length across the top is called B1. This is a subscript. The length across the bottom is called B2. So here's the formula, and we're going to solve this formula for B1. So we want to get B1 by itself. Just like we did with the temperature formula, we're going to start by focusing on this fraction out in the very front, h over 2. And the reciprocal of h over 2 is 2 over h. So just like what we saw in the previous problem, multiplying this by its reciprocal is going to cause the numerator and denominator to be the same, 2h divided by 2h. It doesn't matter what the numerator and denominator are. If they're ever the same, it's just equal to 1. So what's actually happening here in the formula, if we multiply both sides by 2 over h, the left side we have 2 over h times a. The right side, it was 2 over h times h over 2. And then we'll bring down that parenthesis quantity. So all of these pieces here will cancel. That 2 on top cancels with the 2 on bottom. H on top cancels with the h on bottom. And then technically we don't need the parentheses for this part. Let's think about the last thing we need to do to get B1 by itself is to get rid of B2. B2 is being added, so we're going to subtract B2 from both sides. Now finally we have B1 by itself. On the left side we have 2 over h times a minus B2. Now the other way that you can write this, 2 over h times a, that a is really the same as a over 1. So it's really the same thing as 2a is the numerator. H times 1 is just h for the denominator. And that's how we solve literal equations to get a variable by itself.